This is Weekly Review, question 5. I use textbooks, class notes. Yeah, so oh my god, you didn't see that. Jesus. That wasn't there. This is like the 7th time that I've recorded this video. So sorry. Okay, so the first question is asking if we wanted more P53, what would be the technique that we would use? So we would use transfection and we use the overexpression vector. So basically what would happen is we would basically want to get like a cDNA of the thing, the molecule that we want to inject into the cell. Then we would have a enzyme, basically a digestion enzyme, eat away at it. So we're just gonna put that right here, and then ligase would come. Whoa, what is that, man? So ligase would come in and it would just seal it, so that way it's just one full thing again, and then we would be able to transfect the cell. So since we want to make more P53, we want the P53 gene to be over here. And then for promoter, we're going to put CMV. And that's basically saying that the promoter is always going to be active, so that way P53 is always active. So we would transfect the cell with P53. So say if we had, is this going to be the SICON ones? No. Is it going to be the SICON ones? Maybe. I don't know. So say we had a cell, a plate with cells. Can you even see that? Hello? Okay, we guess we're going to go this way. And then we had P53. It would be so much easier if I did this the other way, but I'm not going to. So basically, for background, P53 helps activate GAD, which is the growth arrest in DNA damage. It basically thrives when there's DNA damage. So say we have a minus UV. Jesus. Oh my god, that looks awful. I'm just going to write this over here and maybe just like shove this. And then we have a plus UV. We have cells. And we have P53. So in this case, for the overexpression, in the minus UVs, we would not see much. Because, actually no, because it's in the 293 T cells. Okay, so there is damage. I lied. I'm a liar. There is damage. So we will see some P53 active. We'll see more in the, oh my god, please don't shut off, in the P53 minus UV, just because there is damage. But for the plus UV, since there is more damage, you are going to see more in the plus UV than the minus UV, because it does thrive in that damaged environment. So I'm just going to move on to question 2, because that's all I got. That's all I got for you. And I know, I'm using my hand. Do I have an eraser? I might. No, I don't. No eraser. You're stuck with my hand. Okay. Second question is asking about GAD45 promoter activity. What technique will we use? We would still use transfection. However, instead of overexpressing, we want to make luciferase, which is just, it allows for the cell to basically illuminate. So it measures promoter activity through the fluorescence. So in this case, we would want to make luciferase here. The same thing would happen with the eating away of the enzymes and stuff. So I'm just going to abbreviate it as luciferase. But then the GAD45 would go right here. And that would be our promoter. So in this case, we have 4. Wow. I'm so sorry. So we have cell, and then luciferase. I know this is so bad. So sorry. Luciferase, so we have, I want you to be minus UV, plus UV. So, oh my lord. So because GAD is making luciferase, and GAD is the growth arrest plus DNA damage, it's going to thrive in an environment where there is damage. So because the cells do have damage, but they don't have, well, they do have a lot. I can't even say that. Anyway, so there is damage. So you are going to see something for minus UV cells and then minus UV luciferase. Just because there is still some damage. So sorry, it just started to downpour. So on a graph, I guess I can just like right here. So you're gonna see some stuff for the minus UV. So when we get to the plus UV, there is a lot more damage. However, we are making the luciferase gene, so because these are just the cells, you are still going to see the same amount for that as like the minus UV. But when we get to the luciferase for the plus UV, there's going to be a lot more just because it is making that gene, and you are going to see so much more activity. Wow, you probably just saw my cat jump over. He's the zoomies. Yeah. So all of these cells, there is damage, but because it is making the luciferase gene, and GAD does thrive in a damaged environment, where you're going to see the most is in luciferase plus UV. So, Maui, stop. He's biting my sweatshirt for reference. So, the third question is asking what would happen if siRNA was added to that. And basically, what siRNA does is it decreases the amount of mRNA, which is not the best. Not the best. I mean, it's helpful for things, but it's not the best. So because siRNA is decreasing that mRNA, if it was added in the same way as luciferase, what would happen is the damaged UV luciferase, it would actually, did I say that right? The damaged cells with the plus UV that produce luciferase, that amount would decrease. I know, I'm sorry, I'm using my hand. I know you're going to kill me. It's going to decrease to basically the same amount because, again, the mRNA is decreasing and this GAD is producing luciferase. It's supposed to thrive in a damaged environment, but because the siRNA is decreasing that production, it is going to basically either just be a little bit above, or it's going to be the exact same as the others. Yeah, that's all I got. That's all I got for you. Good night.